everybody. Welcome to another online regular meetup by ngParty. This one is a very special meetup. It's a little anniversary. It's 30th meetup. So welcome again. Before we start, I would like to thank our main supporter, Lysport, which is helping us to run our thing for a couple of years. And it's a company that truly understands open source and the community support. So thank you, Lysport. It's much appreciated. And let's start with the intro. A little bit about ngParty for those that are new to this meetup. ngParty is a next generation development community group based in Prague, Czech Republic. We founded this meetup in 2015 with William Elischer and Mario Vejlupek. And it's mostly about JavaScript. Some of you may think that ng stands for Angular. Actually, it's not Angular, it's next generation. So now you know. What about setup for this year? Unfortunately, there is still COVID, so we need to keep doing this online. And we changed the format to have these meetups only for 1 hour with one special guest and covering one particular topic in a more deep dive-ish way. And after the talk, we are having Q&A, so you can ask any questions that you may have. Of course, if you're interested to join our meetup and present something interesting to the world, please don't hesitate to submit your talk. We will reach out shortly to your proposal. If you want to follow us or help us spread the word, we are the various social media, as you can see on the screen. We are also having our private Slack channel. If you want to, let's say, talk about your proposal or anything related to technology, you can join it as well. We are also on GitHub. We are doing open source besides this meetup. And you can check our website or our YouTube channel where you can find previous meetups or recordings from previous conferences. All right, and what's today's agenda? We're gonna have 3 things on our plate. So first is our traditional TLDR, which means too long didn't read. It's a lightning talk with various interesting things that happened in the world of JavaScript for the last couple of weeks. Then we're gonna have our special guest, Andrei Pfeiffer, talking about the thorough analysis of CSS-in-JS. And after his talk, we're gonna have a Q&A session. And regarding Q&A session, we are introducing a little bit different format. Obviously, you can still ask questions via our stream chat. And a new thing that we're introducing for this particular meetup, you can join us live in the studio. So after Andrei's talk, I will finish the link, and you can join us live and become famous because you will have some screen time and ask any question that you might want to ask. All right, and let's commit this and continue with our meetup. So next up, our lightning talk, TLDR. So regarding releases, recently there was a new release of TypeScript 4.3 beta. There is a link. You can check all these details. New features are being added to the classes ecosystem. So if you are very heavy into OOP, this release get you covered. There are also new features related to private capabilities of JavaScript in classes. So yeah, check it out. If you don't know what NX is, it's a extremely good tool for handling monorepos for JavaScript projects. And so recently there was a version 12 release, which is quite breaking or exciting, let's say, because until now there was no ability to plug in different languages, right? Let's say you have a monorepo with JavaScript, you are covered by default. But with NX12, the core team introduced a pluggable architecture. So no matter what language are you using in your monorepo setup, you can plug your particular language into the NX workspace. So check it out. Another release, there was Chrome 90 released recently. It has a lot of features, obviously, as usual, but one standout feature is addition of declarative shadow DOM. What that means, it's a part of web components specification, and this is a crucial part of greater web components adoption, because with this particular feature set, you can now support server-side rendering with web components, which wasn't possible until now, but now it is. So exciting times ahead for JavaScript ecosystem. Regarding articles, there is this article from Martin Koníček. We also had him at one of our conferences, and he wrote a guide about how to become a tech lead. It's very interesting reading. I'm very happy to see this kind of article. I'm tech lead as well, and most of those points that he described are things that I adhere to during my daily job as well. Another one, also from Martin, is how to do meetings. I mean, meetings are very crucial part of communication, even in this COVID era, and they are quite hard to do a meeting in the right way. And again, this is an excellent write-up from Martin. You can follow these practices to run effective meetings in your organization. Last interesting article was released like last week by Surma, is a dev advocate at the Chrome team, regarding WebAssembly and JavaScript. So if you want to learn more, it's a quite comprehensive article. Check it out. There is also this interesting tool called Grex. If you are familiar with regular expressions, this approaches things from the opposite way. So you write your sentence or something that you want to create regex, and this tool will create from your sentence the regular expression, which is mind-blowing. Like, I don't know if you are skilled in regular expressions. I have most of the time issues to write those on my own, but this tool is it's really a magic. Try it out. It's great. Regarding Git, Yuri Strumpflohner recently shared a tweet about setting up case insensitivity in Git repositories, which is again very crucial, especially if you are in a case insensitive system, which macOS is, for instance. And this setting will save you a lot of trouble. Let's say if you're renaming files from and changing casings, that can become a huge pain. I ran into those in the past, and trust me, you don't want to get there. So just check this config, set it up, and you are good to go. Last interesting thing on the open source ecosystem, author of ngParty.js, Christian Bote, which was the host of our latest meetup, the author of ngParty.js, created this interesting initiative to shave off some kilobytes, in his case bytes, from the project, and you will get paid if you shave a byte. So you will get $1 for every byte. This is extremely interesting, and I really like it. So check it out. Try to shave it off and earn some dollars. And that's it. And next up, the main topic of this meetup, we're gonna have our special guest, Andrei Pfeiffer, talking about a thorough analysis of CSS-in-JS. So welcome, Andrei. The stage is all yours.
Yeah, thanks, Martin, and welcome everyone who is joining the stream. Yeah, just give me a couple of seconds here.
No worries.
Okay, so this should be working.
Yep, we are sharing your screen.
Yeah, okay, great. So yeah, thank you, Martin, and thank you, ngParty, for having me on this special 30th meetup, and allow me to share my my experience and to share my enthusiasm regarding this thorough analysis of CSS in JS. To introduce myself, my name is Andrei Pfeiffer. I live in Timișoara, which is a pretty large city in the west part of Romania. I work as a code designer at Espresso. I like code and I like design, so I like both of them. I'm mainly focused on UI and front-end technologies, both on web and mobile. I'm also pretty involved in the local community, in the technical community. That's why I'm organizing tim.js, which is the local JavaScript meetup in Timișoara, and also revo.js, which is a 2-day conference, not-for-profit, organized by the community, which hopefully we'll be able to organize the next year offline. Let's hope so. Fingers crossed about that. And in case you want to get in touch, you can follow me on Twitter. My handle is Pfeiffer_Andrei. Pfeiffer is spelled just like Michelle Pfeiffer, and my DMs are open, so you can get in touch with me easily. Okay. So this analysis, this analysis of CSS-in-JS is basically more than 2-month study that I have done at the beginning of this year, in a pursuit to discover which CSS-in-JS library is more suited for a specific project that we might have. There are more than 50 libraries out there, so it's very difficult to make a choice. So I have only 40 minutes at my disposal, so it's going to be pretty difficult to fit all the content in 40 minutes. So I won't be able to do that. That's why I will only cover part of the entire content. So if you need more context about a specific topic, or need to get into more details, or you need more information about some topics that I haven't covered in this talk, please post your comments in the comment section, and I will be more than happy to discuss them at the end of the talk. So to begin with, the motivation, why did we, or myself, started this analysis? I've been using CSS for more than 20 years, and I came to the conclusion a long time ago that CSS is not trivial to scale. It's very difficult. I've tried basically probably all the methods to scale, to help us scale CSS. We tried the best practices in 2006 or 8 or something, which are so many of them. They are way too complex. They are very difficult to teach to somebody else, and almost impossible to enforce on a larger project with a big team. Then methodologies were invented, like object-oriented CSS, BEM, which is block element modifiers, Max, which basically encapsulated all these best practices. But methodologies really are, again, difficult to scale. They are difficult to enforce on an entire team, and difficult to learn as well. And there are so many of them. CSS encapsulation was the next step, and is a great step forward, which fixed a lot of the shortcomings and limitations of CSS methodologies. We have built-in encapsulation in Vue and Angular, which is awesome. We don't have CSS encapsulation by default in React, but we have CSS modules at our disposals, and basically they fix the same problems, and we get the same result if we use CSS modules. So that's awesome. But we still felt that CSS encapsulation is not enough. And this is the main reason is that CSS as a language is not type safe. And the tooling around CSS doesn't provide us with the benefits of type safety, as we have in the case of TypeScript, for instance, or some static type checkers. That's why this analysis basically is an exploration to see if we can have the same benefits of type safety, but for our styles as well. Because let's face it, styles are part of the component. So why treat styling and CSS in particular differently than our JavaScript code or JSX or whatever language are we using? We want to have the same benefits. And when I say type safety, I refer to type checking. So making sure that you don't misspell a class name that you use in your components, or the class name that you are using is not defined in the CSS file. having a feature such as go to definition to be able to easily identify which styles apply to a specific class name. So to be able to switch back and forth between the style definition and the style usage. Be able to safely and confidently refactor our code whenever we feel we have to. Detect unused code and remove it. And also, if we have a type system and we use a lot of, not a type system, a design system, sorry. If we have design system, then probably we will have some sort of theming and some design tokens that we would want to use in our CSS code. And we probably want to share these design tokens between our CSS code and the JavaScript code. So having all these features in place will basically allow us to have a more robust and type-safe code. And I have the feeling that CSS-in-JS is the solution to all these problems and the limitations that CSS encapsulation alone does not provide. And of course, if you're using TypeScript, you get all the benefits that TypeScript provides you for the components. But now we can apply all those benefits to the CSS language as well. Now, before we get into the content of the talk, I have some disclaimers to say. So I have not built my own CSS-in-JS library, and I don't work for any of the libraries that I will mention in this talk. I have no motivation to promote or thrash either of them. I have no prior experience with the CSS-in-JS, so this is the first time I've actually used CSS-in-JS, although I knew about it for a long period of time. So I've equally used all the libraries that I will present here, but I have no extensive experience with any of them. So you can safely say that I'm a jack of all trades, a master of none in this regard. And this analysis is basically a pursuit towards a better understanding of the tools and all of the features that these libraries provide us. Because let's face it, they are tools that help us to help us do our daily work as developers. All the content in this talk is based on limited know-how, is based on personal research and experimentations and discussions with the maintainers. So if you feel that you have anything to add to this talk, please feel free and post your comments, and I will be glad to discuss them at the end and after the talk as well. Okay, so let's jump into the content. So with this analysis, we were looking for all the CSS-in-JS JavaScript libraries that provide server-side rendering. We wanted to have to be able to implement a wide variety of applications, and server-side rendering is a big topic, so we needed this as well. For this, we were looking for an easy integration with the Next.js. We really like Next.js as a JavaScript framework because it provides a hybrid rendering both on the client and the server. So an easy integration with Next.js was definitely helpful. Also, as I mentioned before, type safety was a must, and for that we looked for TypeScript support. Now, there are more than 50 libraries out there, as I mentioned before. We took around 20 of them, 20 of the most popular ones. Now, not all of these libraries met our minimum requirements. Some of them were outdated or lack some documentation, or we couldn't integrate them with Next.js. So we focused on 10 of these libraries. These libraries are Fella, Style Components, Emotion, Style JSX, Stitches, JSS, Goober, TypeStyle, Treat, and Compiled. Now, instead of going through each of these libraries individually, which won't be a very good idea, won't be very productive, let's look at their features. And there are so many features that we have to analyze, so we will go only through some of them. Some of them are common to all the libraries. Some features are common but a bit ambiguous, so we'll have to discuss them in a bit more detail. the most interesting ones are the distinct features. Some features that are supported by some libraries, others that are not supported, and others that offer a limited support. Okay, let's start with the common features, and we'll go pretty quickly through these because yeah, they are common and probably you know about them. Server-side rendering, as I mentioned before, all of the libraries provide this, so I just wanted to get it out of the way, or to enforce once again that all the libraries, all the 10 libraries that I mentioned before, support server-side rendering. None of the libraries implement or use inline styles. Inline styles was a method to output the styles, is an older method that is not used anymore by any of the library, which had some limitations and some problems, because with inline styles we cannot easily implement specific CSS features like some pseudo selectors or media queries, and also it has some important performance problems as well. So that's a good thing that none of the current libraries use this approach anymore. All the libraries, of course, implement style encapsulation because that's pretty important, and from my point of view, it should be a de facto thing and de facto feature. This style encapsulation is provided via uniquely generated class names, similarly to CSS modules. Now, there are different mechanisms and different algorithms to generate these class names, but this is a pretty involved topic and detailed topic. If you are interested in this, we can discuss this at the end. But I don't think it's a very crucial factor in choosing which library to adopt. Now, global styles are not very recommended to be used. That's why we have style encapsulation. But there are some use cases for global styles. For instance, if you want to apply some CSS reset, for instance, or you want to define some global typography for your website or application. So global styles are useful in specific situations, and all the libraries provide the ability to add and to define global styles using various APIs. Because none of the libraries that I mentioned before implement or use inline styles, basically we get access to the entire CSS syntax. So we can pretty much use any CSS feature that is available in CSS-in-JS. Now, we've only tested the pseudos, like pseudo elements, pseudo selectors, keyframe animations, and the media queries. Each library has a different syntax and different APIs to provide support for these features, but all of them support them, and they work great. Okay, moving on to the more ambiguous features. So one feature that is, let's say, less ambiguous, but we should get it out of the way. There is the dead code removal feature. Almost all the libraries promote themselves of being able to remove dead code. So let's see what this dead code actually refers to. This works great at a component level. So when you remove the component or don't import it anymore, all the styles that are within those components won't be bundled anymore. So they will be actually removed, which is a very good thing. We need that. However, it doesn't work at CSS rule level. So most libraries provide some way to nest CSS selectors, like child selectors or pseudo selectors, parents, some dynamic styling. It's not a limitation of CSS-in-JS. That's basically a big problem in itself. So it's not easy and probably impossible to solve regarding any solution that you might try, because it's very difficult to determine at build time which of the selectors will or will not be used at runtime by the component. So just something to keep in mind, that it doesn't work at CSS rule level. So you might ship some styles that are not actually used in the components. Another pretty confusing topic, for me at least, was critical CSS extraction. Most libraries also promote themselves of being able to extract critical CSS. Now, critical CSS refers to the CSS that is generated during server-side rendering. And the first time I've read this feature in the documentations of the libraries, I thought that it referred to above-the-fold CSS. And indeed, if you search the entire internet, the first page of Google results will give you articles that associate critical CSS extraction with above-the-fold CSS. Above-the-fold CSS being the CSS that is needed for the initial viewport of a website that is loaded into the browser. Now, when you talk about CSS-in-JS and critical CSS extraction, it does not refer to above-the-fold CSS. I couldn't find any evidence that there is a JavaScript CSS-in-JS library that is able to extract this above-the-fold CSS, because it is a very complex and non-trivial thing to perform. It's very difficult to automate. What it does refer to is the CSS that is required for the initial render of a server-side render page. So basically, it removes all the dynamic styles that are not required to view the initial page. So let's say you have some styles that only apply after you click a button or some event happens. So those dynamic styles won't be bundled as critical CSS. So that's an important thing to keep in mind. Critical CSS extraction in CSS-in-JS does not refer to above-the-fold CSS. Okay, so let's move to the interesting part, the distinct feature. I will only go through 2 of these features because the time is limited. So yeah, let's jump into the topic. So the first and probably one of the important things is, how do we define the styles? There are 2 different syntax that these libraries support. There is the tagged templates syntax, which uses ECMAScript 6 tagged templates, basically define your styles into a string, into a template string. And there is the object styles syntax, which basically defines styles in a plain JavaScript object. Now, there are some differences in the syntax. So when using tagged templates, you use the same syntax as you would use in plain CSS. So you write the CSS property names in kebab case, and you don't have to wrap the values in quotes. But when using object styles, we must use the camel case syntax for CSS property names, and we have to wrap the string values in quotes, double quotes or single quotes. We won't get into the debate. We can use variables or constants in both the syntaxes. In the case of text templates, we must use string interpolation, and in the case of object style, well, we can use object properties or variables or constants like you would normally use with an JavaScript object. Now, in the case of text templates, because all the style definition is basically a string, in order to get some syntax highlight and code suggestions in our editors, we need a plugin, because without this plugin, we will basically see a string, right? We don't see any syntax highlight. Now, fortunately enough, all the libraries that support this the tag templates syntax also provide an editor, a plugin for the most popular editors out there. So that's not a problem. In the case of object styles, syntax highlighting is supported out of the box because, well, the syntax are JavaScript objects. So we get the same highlight as a regular object. Regarding code suggestions, the library authors need to provide types for the definitions, right? Either flow types or TypeScript types, and pretty much all the libraries do this already. So there is, they are supported pretty much for any library that we might use. Now, the differences between the two syntaxes, besides personal preferences, there are some other differences as well. So, for instance, if you would have an existing CSS code base and you would want to migrate to CSS-in-JS, for sure it would be much easier to do this migration if using a text template syntax, because we wouldn't have to rewrite our entire styles from a kebab case to camel case, or to wrap our values with codes. I couldn't find any tool that would automate this process. Probably it could be done to some extent, but it would be it would incur more effort in this regard. Now, regarding object styles, they are much simpler and lighter. Lighter because text templates require an additional parsing step, an additional processing, because all that string needs to be parsed by usually by a bubble plugin. So it is required an additional processing. Not very much, but there is it's a bit an overhead. So this is the support matrix. Object styles are supported by most analyzed libraries, with the exception of styled JSX. Other libraries, so some libraries support only one syntax, others provide the other syntax. There are some libraries that support both syntaxes, but as you can see, the support is greater for object styles, and most libraries support this. Tag templates, for instance, in the case of Fela and JSS, are only provided via a separate plugin. Okay, the next and final topic, and probably the most comprehensive one, is how the styles get into our clients, our browsers. So there are two methods to output the styles. The first method I will call runtime style sheets. I don't know if this is a name, but I will use this name for the rest of the presentation. Using runtime style sheets, all the styles that we define for our components get bundled within the JavaScript bundle during our build step. So that's important thing to remember. The styles are inside the JavaScript file. And now somehow they need to get from the JavaScript file into the DOM as CSS styles, right? And in order to do that, there is an additional JavaScript code, which I'll call the library runtime, which takes those styles inside the JavaScript bundle and basically injects them into the DOM using various APIs. There are so many APIs. They get injected as style text appended to the head, or they use directly the CSS object model APIs. So there are different methods, and it's very advanced topic in this regard. We can discuss about this at the end if you are interested. But I won't go into much detail because it's really advanced, and there are so many ways to do this. Now, the second method is static CSS extraction. So instead of bundling the styles as JavaScript code, some libraries are able to extract those styles and generate a static CSS file, a regular CSS file, just like, I don't know, SAS does or CSS modules does, right? So you get a static regular CSS file, which we can attach to our documents as a link tag. And the components basically, and the JavaScript bundle will contain only the components, and we don't require any runtime in this situation because, yeah, the styles are already there as CSS. Now, there are some important performance considerations that we have to keep in mind regarding these two solutions. So let's consider client-side rendering with runtime style sheets. So when we are doing client-side rendering, in the case of a single-page application, for instance, we get a pretty empty HTML file because nothing is rendered on the server. We get a large JavaScript file, JavaScript bundle, which as we said, as we've seen, contains the styles as well. And we also need an additional runtime. When we are performing server-side rendering, the HTML will be, of course, larger, right? Because all the components are rendered on the server as HTML. And we also need to include the critical CSS when we are doing server-side rendering in order to be able to render the page correctly, right, in our browser. One thing to keep in mind in this situation is that the critical CSS, everything that is included in the critical CSS will also be included as JavaScript styles in the JavaScript bundle. I don't think this is something that can be avoided. Probably library maintainers are able to provide more details in this regard. But I think all the libraries have this shortcoming, let's say. But it's something that is happening, and we have to be aware of that. Now, so this is the file size, typical file size for the runtime style sheets. Now, when we look at static CSS extraction, of course, the HTML will be much lower, right? Much smaller, because we don't need the critical CSS, because all the styling is found in the CSS file that is statically generated. And also, the JavaScript bundle won't contain the styles anymore, and we don't need an additional runtime, right? So when we look at a file size point of view, static CSS extraction looks great, right? Because it's much smaller. Another thing to keep in mind is that HTML is difficult to cache, right? It's not trivial to cache, while CSS and JavaScript are cached by default in the browser if we set the proper HTTP headers. Now, for the next diagram, I will use the graphics that Chrome DevTools uses. So we will look at the HTTP requests that are performed in the browser. So the first part, the outline part, is the time to first byte, is the time it takes for the browser to make the request and to receive the first byte of the response, right? It's called the time to first byte. The second part, the download part, is the time it takes for the actual content to be downloaded from the server to the client. Now, on a fast Wi-Fi, we have a certain amount of time that it takes to get the time to first byte, which, by the way, is pretty much the same for all the requests, right? This is the latency between the client and the server. And even if we have a large file, it would be downloaded very fast because we have a large bandwidth on a fast Wi-Fi. If we look at a slow mobile, for instance, the time to first byte is going to be definitely a bit larger, but the download part is going to be is going to take much longer time to download that content or that resource, because the bandwidth is much smaller. So keep this in mind for the upcoming diagram. Okay, so let's look at how is a typical website loaded with an empty cache. So when you have an empty cache, we fetch the web page. There is an HTML that includes also the critical CSS is one HTTP request. After we download all the file and we parse it, the browser parses it. It can download as well the resources, the JavaScript resources that might be included at the end of our document. And we can load these resources in parallel. Now, after the CSS, after the HTML and the entire HTML is downloaded and parsed, the browser can start painting something on the user screen. This is the first paint. And there are various metrics regarding first paint, like the first contentful paint, largest meaningful paint, and different first paint metrics. But when we look at static CSS extraction, we have to, or the browser will download the HTML file. Then it will see that there is a CSS resource in the head. So we'll make another request for that CSS resource. And probably if we include the JavaScript bundle at the end of our document, after it finished downloading the CSS, it will load the JavaScript as well. Now we can move the JavaScript into the head of the document and download them in parallel, but that would probably incur other problems. But the main idea is that the first paint will definitely be after all the entire CSS is downloaded and parsed, because remember, CSS is a render blocking resource, and usually when usually that CSS file will be a pretty large file, because all the styles on one page will be bundled within one single file. So even though we download less bytes overall, the perceived performance or the loading performance could be slower, right? And pretty much is definitely going to be slower than using a runtime style sheets. So we have to balance these two things out. Now, of course, with a full cache, after we've made our first request, those CSS and JavaScript files are already cached. So this subsequent request will be much faster. And definitely with static CSS extraction, the first paint is going to be faster than in the case of runtime style sheets. So basically, with CSS static extraction, we have a worse performance for first-time users, but a better performance for subsequent users or visitors to our page. Now, again, keep in mind, this is sample data. This is an oversimplified example just to understand like the theory regarding resource loading in the browser. So it's not going to reflect your real application. So we have to measure everything in order to find which solution works best in our projects. Now, to have a conclusion regarding the styles output. So, from my point of view, runtime style sheets, looking at how they work, actually, they look to be more suitable for client-side rendering and for single-page application, because there is this overhead of inlining the critical CSS, and if you pay only once that price in the case of single page applications, that won't be pretty much a problem. But if you pay that price for each HTTP request that you perform in a website, in an e-commerce website where probably most pages will be server-side rendered, well, that's a big difference, right? And also keep in mind that first paint metrics are gonna be pretty much faster with the runtime style sheets. On the other hand, static CSS extraction, from my personal perspective, looks more suitable for server-side rendering. As I said, we transfer less bytes and we get better caching out of the box. But this caching thing is pretty tricky, because we also have to keep in mind or to take into consideration what is the frequency rate of cache invalidation. Because if we rely heavily on caching, but we release every hour or every day, we make a new release and we invalidate the cache, then basically we won't benefit of the caching. So there are a lot of things to consider. Performance optimization is a very broad topic. So yeah, it's pretty huge. This is a support metrics. Only one of the libraries that we tested support static CSS extraction. This is Street. Compiled also has an experimental feature which is not production ready at the moment. There are two more libraries that support static CSS extraction that we didn't include in our thorough analysis. This is Linaria and AstroTurf, but we couldn't integrate them with Next.js. So basically, all these CSS-in-JS libraries are different tools that solve different problems. And if we understand the tools and what problems do they solve, it will help us to make better educated decisions regarding our project that we work on. So you can check out the full analysis. It's available on github.com/Andrei Pfeiffer/CSS-in-JS. I will only show it to you briefly, just to see the structure of the analysis. If my internet is working, hopefully. No? Okay, I have it here, I think. So thank you for caching. Okay, so you can see the motivation, goals, disclaimers, everything that I presented here as well. There is an overview where we listed all the 10 libraries compared to CSS modules, which we used as a baseline, and we've analyzed multiple criteria that you can check out here. Every criteria item is explained in pretty in detail here. Then we have the overall observations, basically the common features that we went through some of them in this talk. You can check this out as well. And then at some point, you get to the detailed analysis of each of the 10 libraries with some overview of the features and then some personal observations. These are pretty much are pretty much subjective details that we observed. Some conclusions, some metrics regarding the file size and how it compares to CSS modules, and the output of the Next.js build. And in the end, I would like to thank to give a special shout out to two persons. So the first person is Martin Hohel for his contributions and suggestions and support in this analysis, because he also helped me a lot to put it together. And also to Oleg Isonen. I hope I didn't pronounce it wrong. Oleg is a maintainer of JSS, and he provided some really incredible constructive criticism and helped me better understand the performance implications of CSS-in-JS, and that was really helpful. And also two more persons, Carl and Alexander, which also helped me. They made some contributions to misspellings and that kind of stuff, and really helpful. Thank you, everybody. And let's make this analysis. Let's take this analysis further. Okay, I'm at the end of the talk. I would like to thank you, everyone. Hopefully, it will help you better make better decisions regarding which CSS-in-JS library you might use for your next project. You can check out andreipfeiffer.dev. You can get in touch with me via Twitter. And if we have any questions or anything that you would like to discuss, I will be happy to talk. So thank you, everyone.
Clap. Thanks, Andrei.
Sure.
Very nice, very nice presentation. So yeah, folks, ask your questions if you have any. And also, if you would like to join us in the studio, you can do that as well. Just go to this URL, which we shared in the live stream. All right. Robin Weser shared some insights regarding duplicate styles in critical CSS-in-JS. Basically, he wrote, we might be able to get rid of duplicate styles with React server components. But until we get those, there is not really much we can do. So,
regarding the duplication of critical CSS?
Yeah.
Yeah. Interesting. Yeah, I haven't thought of that, but yeah, it should be a topic that could be further explored. Definitely.
Yeah, that sounds definitely interesting. I haven't played with server-side components yet, but
yeah, me neither. They are way too fresh, way too hot.
Yep. Oh yeah. Nice. There are no questions, so I have a few questions, if you don't mind.
Yeah, sure.
So most important questions, like you did this research, you shared it with the world, which is absolutely awesome, and thank you for that, because you spent a lot of time on it, which was not for free, right? So this is great, and I would be interested. Which library did you choose for that particular project? You've been doing this analysis. If it's not confidential.
I thought I will receive this question, and I don't know if so we chosen Treat because we used a lot of server-side rendering, and this looked like a better choice for us. Now Treat will be replaced by another library, so by vanilla extract that's currently in alpha, and we will check out also after it has a stable release. So yeah, that's why I was not sure whether to say something about Treat, because yeah, it's a good thing and a bad thing at the same time, because it will be replaced by I mean, it will be maintained anymore, I guess, but they won't put any more development effort into it, as far as I know. But
Right.
there is some migration path, as I saw on the documentation, and I don't think it's going to be very difficult to migrate in case we choose to migrate. So yeah.
Cool.
As I
Thanks.
only because we had a lot of server-side rendering, and we banged our heads a lot whether that's a good solution, because at the beginning, when you look at the static CSS extraction, it's definitely better than the others, right? Because you ship less bytes, but yeah, it doesn't cover all the other aspects of performance. So
Yeah,
not easy.
definitely.
Yeah.
Cool. So we have a guest at the stream.
Nice.
Hello, everyone. I would like to ask if you measured runtime cost of the runtime libraries, but how much time it adds to the static CSS. I mean, the parsing of the extra JavaScript and interpreting and applying all the styles in the runtime.
So yeah, the performance regarding the runtime. Wow, that's a pretty broad topic. That was out of the scope of our analysis. Let me share this with you. So if you go to disclaimers, what you won't find here, which solution is the fastest, as we're not concerned about rendering performance metrics. There is a benchmark for this. And there are various libraries that are implemented here, and I think Cristi Bote for Goober also used this to benchmark his library. So you can check out probably this repo, this benchmark. We didn't cover any rendering performance in this analysis. So
okay, and did you measure somehow how much the runtime styles costs above the static styles? I mean, if there is some baseline, like if you use runtime styles, it will be always like some percent slower above the static CSS, or is it even measurable from the performance view? Because I read, I read probably a year ago that the CSS-in-JS is costly, and I read a lot about the libraries that allows you to export the CSS into status. You mentioned AstroTurf or Linaria, which should help in this way, but I did not read any benchmark and never digged deeper into this topic. So I'm curious if you have some idea how much the JavaScript might cost. Maybe time to interactive might be a little bit slower because first paint will be really quick, but interaction will be slower.
Well, the time to interactive was definitely a topic that I thought about it a lot, but I don't think there is any way to determine whether one approach or the other is faster. I mean, it depends a lot whether you have an empty cache or a full cache. That's for sure. It's very difficult to. It depends on how longer or how long it takes for this guy here to download and parse, depending on your internet connection, depending on your latency, and how long it takes for this guy here to download and parse. So basically, if we look at this diagram, which is, as I said, like a sample data, and it doesn't reflect the real use case. After this thing is parsed and this thing is parsed, then basically you can make some comparison between the two use cases. But I don't think it's deterministic. Like it depends on so many other aspects that I think it's almost impossible to make a definite decision or to draw a conclusion that runtime style sheets will render a slower or a faster time to interactive than static CSS extraction. It's way too complex, and there are so many moving pieces and so many variables that you have to take into consideration before jumping to any conclusion. So that's why I couldn't draw any definite conclusion in this regard.
Yes, in the end, it's best to just try any CSS-in-JS with your concrete application and do the benchmark in your environment as usual.
I mean, one thing that I'm looking forward to is compiled, because compiled will basically be, well, there is I think another, I don't know exactly if style 9 also supports both these methods. But basically, if you want to measure, then you have to have a library that supports both output methods, and to switch between the two of them and have a already large code base implemented and measure the differences between the two of them. But before you have that, then it's really difficult to make these measurements. Because let's face it, if you use any other solution, any other library on a large code base, you won't re-implement everything or an entire web page or a large web page to be relevant with a different solution just to do the measurements, because it's a tremendous effort to do, right?
Yes.
So only if you have the two implementations fully, then you can make the proper comparisons. Yeah, but definitely.
Right. Thank you.
But sorry, I don't have a definite answer. I would like to find that answer as well, actually.
Okay, thank you. Tremendous presentation. Thank you very much.
Thank you, and glad to be of help.
Cool. Any more questions, folks? Don't be shy. All right, I have another question. Andrei.
Shoot.
Obvious question, right? Like, which library is your favorite?
Come on, man. You're killing me. Which one is the best? No, I don't. I don't have. Sorry, as I said, for me they are just tools. I will not get emotionally attached to these libraries, and yeah, I don't think it would be fair to, even if I had one that I preferred, it wouldn't be fair to the others, because this analysis and this presentation is supposed to be like totally objective. But actually, I don't have personal preferences.
Cool. That's a reasonable answer. Thank you very much.
Evasive answer, but what can you do?
It is what it is. Exactly. Yeah. No more questions. All right. Last question for myself. Between the dynamic and static extraction, is there any difference in terms of lazy loading? Let's say I have a part of an application that it's not loaded every time, right? Because users are not using this all the time. So it's a good practice to make it lazy loaded, right?
Mm-hmm.
Only if I click on a particular link, I want to load the additional chunk or the JavaScript bundle and render that part of application lazily. And in this kind of scenario, isn't that like additional overhead if we use CSS extraction? Because then we need to do 2 HTTP requests, right? One for CSS, one for JavaScript. So how is this situation, let's say, being handled, or is the issue or not? That's the question.
Interesting idea. Interesting question. Lazy loading. Well, this basically, as far as I understand, it really depends on the bundling that you are doing, on the framework and the bundling that the framework performs. So I can only answer this question from a perspective of Next.js, because I am familiar with the build system in Next.js. So in Next.js, a server route, or a route that is rendered on the server, will, as far as, for instance, treat is configured, it will bundle in that static file all the static and dynamic styles that are used on that page. So, so when if you lazy load the component, you will only fetch the JavaScript code required for that component, and the styles, as far as I know, and I hope I don't get this wrong, but the styles will already be included in the JavaScript, in the CSS file that is that CSS file for that specific route. Does it make sense?
Mm-hmm. Yeah.
And
but still, like you will have one request versus 2 requests, like dynamic CSS extraction. I guess the answer is measure, right? Like it might be faster in some circumstances, in some other circumstances it might be faster.
Yeah. One thing, just me look at this output here. So our demo application, which is a really shitty tiny application, had 2 routes. You can see here is the index route, which contains the CSS for that index route, and we have another route which has another CSS, and there is the common CSS that is shared between these two routes, or all the routes. So when you make the first request, you will basically load 2 CSS files, the route specific and the common one, and yeah, that's it. And when you go to another route, it will load the other CSS.
Yep.
But
right,
this is again a very simple application. We didn't use the lazy loaded components, and yeah, it's oversimplified. So
yeah, no worries.
Yeah. Mm-hmm.
I mean, we can definitely, or contributors can definitely send any pull requests to cover also this kind of metrics, if it's like important, of course.
Yeah, exactly.
To the open source ecosystem. Cool. So we have no more questions.
Okay.
So I will say this is it. Thanks a lot for coming, Andrei. It's a pleasure. It was a pleasure to have you, as always. And thanks everybody on the live stream. It was also recorded, so you can catch up later on and check it out. And definitely check Andrei's GitHub repository. There is a ton of information. Much appreciated. All right, folks. So take care, everybody, and see you next time. Bye.
See you. Ciao.